We've been getting not complaints, but hints that we are not very good on the testing part of the JavaScript. And we've heard you, so let's talk about how to write tests for your Enonic apps for the code written in JavaScript. We'll start, surprisingly enough, with FAQ, something that you would typically end with. But what is Jest? And quick raise of hands who used Jest before? Yeah, okay, not so many, that's good. And you're the right audience. So this is an open source, of course, testing framework built with JavaScript for JavaScript. It doesn't mean that it cannot be used for the code written in other languages, but they have to be JavaScript based. So any JavaScript framework will do. Why Jest? Why not a Jasmine or a Karma or Sinon? It's extremely easy to set up. So basically, in its minimal version, it requires no config, but that assumes that you are writing the vanilla JavaScript. You have to name your folder with tests specifically, and you have to name your tests also in a very specific way. But the bottom line that you can run it with no config. It's created by the guys from Facebook, the same people who made the React, which means it's natively integrated with the React, and it means it's going to be supported for a very, very long time. It's very fast because it runs the tests in parallel. So thanks to that, it's extremely fast. Mocking comes out of the box, so not all the frameworks have that. Sometimes you have to kind of install some plugin which will enable mocking. Not here. Here you get the whole shebang out of the box. It supports TypeScript, which is extremely important for us people who love TypeScript. And here I wrote via a separate RPM plugin, but now it's NPM plugin. It's just me not having a good site. And it's very well documented, which is last but not least. Documentation is very good with examples and everything. Another important question. Can you write tests only for client-side or server-side code? And the answer is yes, which means both. What frameworks can Jest be used with? This is really important. And I checked, and I found the guides for integration with Jest for the following frameworks: React, Redux, Vue, Angular, Gatsby, Next, and Nest. But I think there are more. It's just I spent like 10 minutes looking for it. But the support, as you can see, is very good. So whatever you're using, if it's not very exotic, you will find the integration. You will find tutorials and guides, and maybe even the code examples. Okay, so I guess I hope I answered why we picked Jest as our go-to framework. Good support, TypeScript, and so on. Let's look at the setup, how hard it is to set up Jest. If you are on JavaScript, you are just doing this. You install the Jest, and that's it. It gets added to your package.json, and you're good to go. If you are using TypeScript, then you would use something called ts-jest, and that will include both the Jest and the type definitions. So this is also easy, and I suggest that you use the wizard to generate a config file for you. It will ask some questions like what framework you're using, where do you store the tests, and so on. But the good part is that it will generate the entire config for you. If not, then go to the docs, look at the different config properties, do it yourself. Then you add the script to your package.json, call it test or call it whatever. and do this. Just no cache. No cache if you want to run tests all the time. Okay. And then since we are talking about the integration with XP, we want to add the hook between build Gradle and the npm script. So you add the Gradle task, and you say that okay, this is an npm task, and we want it to run the test script. So this is going to be npm run test, which will execute this script here. And this line is also only if you want to run tests all the time on every build. If you don't want it, then you can remove this line, and then if there have been no changes in either the test code or the source code that is being tested, then it will skip the tests. And the last but not least, add this. So test, don't confuse it with this one. This one is the built-in Gradle task, and here you say that okay, every time that a Gradle executes tests, I also want to run Jest tests, because you may have some other tests. You may have Java tests, you may have some backend testing going on, but you want to include this one. So this will include the Jest tests with your entire test task. Yes, syntax of the Jest is quite simple. So there are 3 key methods: describe, test, and expect. And describe basically groups your tests defined by this one. So test is basically a specific use case that you want to test. And then inside you use expect. So expect basically you send a specific expression as an argument, and then you compare the result, the output, with the matcher. What is the matcher? Matcher is something that looks like this: to be, to equal, to be truthy, to be falsy, to be null, and so on. We'll look at the example in a couple of seconds, so if you don't really understand it, it will be more obvious in just a few seconds. And you can also invert your expectation. So if you want, for instance, to check if value is not equal to something, then you would do dot not dot to equal. Okay. All right. So let's look at example. Now things will become much more obvious. So here is the very simple example. So here you see that I used describe to group several tests here. And the first test is just test that 2 plus 2 is 4. That's it. Very simple. So you have the test. This will actually show up in your log when the test will be run. So then you send the expression as an argument to expect, and you compare it with the matcher. So you expect 2 plus 2 to be 4. Here is a bit more complicated example. Here we compare the object. So here we cannot use to be, because to be is only for the primitives. But here we actually compare the object. So we use to equal. To match the Boolean value, we use either to be truthy or to be falsy here. Yeah, and here it's basically the same, but we invert to be truthy. So this could have been replaced with to be truthy. Okay, looks simple, right? Okay, good. So now we can get to a simple test. So we start really simple. We have this code that generates the Fibonacci sequence for a given number of elements, and everyone knows what that is, right, Fibonacci? It just will return an array of numbers for a given number of elements, and we want to test this, and a test will look like this. It's a TypeScript. So we import them three methods that I talked about: describe, expect, and test. And then we import the actual method that we want to test from the your code. And very simple suite. Describe with just one test. So we check that the first 10 numbers are correct. So we pass the execution of the method to expect, and then we compare it with a matcher. Okay, very simple. No questions here? Okay, looking good. Okay, let's get to mocking. So if you've been writing tests, you should know what mocking is, and it should not be confused with spying, because mocking is actually something that will stop the actual method that you want to test. So it will basically replace the actual method with something that you can control and something that you can inspect. So this helps you to basically isolate the parts of the system that you are testing without actually calling that method. Whereas spying is just checking that some method got called. So this is not everyone understands the difference, but there is a difference. Okay, so let's try and make a simple mock. So we have the source code, which looks like this. This is just you can imagine that this is the first line of your long TypeScript code, right? So we export something from a TypeScript file. And this is an actual XP core library called libcommon, which has the method called sanitize. So what happens if we try and test this code? The problem is that as soon as we do the import of that code, your framework will actually try to import that library. So it expects it to actually exist. If we mock this, if we say that, okay, every time when I see that someone is trying to use the libxp common, don't go and try to find it, but return this object instead. Okay? So since we are using the sanitize method in our previous code, if I can go back to it. Okay. I think I went too far. Here. So here we are using the sanitize method from the library. So that's the only one that we need to mock. Had there been several here, we would have to mock all of them, okay? Not just the sanitize. But here it's enough to just mock the sanitize, and here we actually implement our own behavior, what we want this method to do, and we can control it here in our test. So here we can actually now write the actual test and call the sanitize method, but instead of the actual API method, it's this one that is going to be called. Okay? Is it yes, no, maybe? Okay. So basically you stop the actual function with the one that you can control here. Yes?
Yeah, but the purpose here is, let's say, not to have to start all of XP.
I'll get to that. The idea is that you are not testing the XP, so that's not what you want to test. You kind of trust the sanitize method, but you want to test your own, so you don't have to care about what XP will return. Okay, you just need to make sure that your code works. So you wanted to test your own parts of code, not XP's. And here, Thomas asked the right question. We get to something called mock XP. So your natural question would be, do I really have to mock all of the XP API, like I just showed you? No, because we've done it for you. We've created something called mock XP. And what is that? Mock XP is basically an NPM module, which is currently in the version 1.0, so it's ready to be used. It's, as of now, mocks 9 core APIs, so not all of them yet, but we are getting there. And this is the key part. So you use it to run your tests in a node without actually having XP running. So this is very important. So you will most likely want your tests to be part of your build pipeline. But what happens if it's on GitHub, right? You don't have XP running there, but you still want the tests to be run. And that's where mock XP becomes invaluable. So basically you don't have the XP running, but all of its core methods are mocked. So they will not actually be called, but it's mock XP who will take care of that nothing fails. And you install it like this, as always, and then this is a simple example of how you use it. So here we import libnode. We are all familiar with what libnode is, and something called server. So a server is a mocked XP instance, basically. So here we say, okay, new server, and create a repo with the given name. So now we can pass the server const to any core lib that is mocked by mock XP. So here we say, okay, give me an instance of the libnode for a given server, and now we can use any of the methods that we have in libnode: connect, create, and so on. So here you do that, but all of it happens with no XP running. This is important. So this helps you to not care about XP at all. You only focus the tests on your code, the code that you made. Okay. So this is a more complicated example. So here we use what I just showed you. We used the same connect method, but here we actually use this connection to create a node. Create a node, because it's not going to be created; it's mocked. And here we compare the created node with something that you would expect. Okay. Any questions so far? So no? Yes?
I think not everyone knows what libnode is, but...
Yeah, libnode is Node API in one of the core API libraries in Enonic. So,
storing low-level data.
Yeah, but I think if you work with XP, then you do. So it's like the lib content, libnode, and so on. Yeah. We could have the same example for lib content. That would not change anything because it's all mocked. Okay, that was about mocking and the server side. So let's now look at the client side. And we are going to use React since it's more natively supported. So if you want to write client-side tests, then you would have to install a new environment, which will enable things like window, document, and so on, that you would typically have on the client side. And then you have to change your config for Jest to use that environment. Because for server side, you would use Node here, and then for client side, you would use something called Jest DOM. And we will install React, all the typical packages that we would need for React. And then the source code is very simple, just basic React component that renders hello world. And you see the h1 tags here. So we want to test this one now. And the test would look something like this. Again, the usual suspects, 3 musketeers here. And we import the hello world component that we want to test. And we use something called a React test renderer, which helps you to, to kind of render the React components without doing this on the browser page. And we call it, so render create, and we pass our hello world component there. And then we use Jest to verify that the object that was rendered is what we expect, that it has the h1 tags, that it has the specific text inside, and so on. Okay? Any questions to this? Okay. So, while working on this integration with Jest, we came up with several best practices. And I'm going to name them quickly. It's up to you whether to follow them or not. So we had a long discussion about whether the test should live in the same folder as the source code or not, and we decided against that. Why? Because we are using TypeScript, and if TypeScript tests sit in the same folder, then they will be built as the source code. And they will be bundled with the jar file. You can avoid this, but it's quite complicated config. So we decided that tests should be in a separate folder called Jest, and we also decided to separate the client side and server side into separate folders. We name our tests with the .test.ts postfix. So this also helps to configure it, that we tell Jest don't look at all the test files, look only at .test or .spec, as some people use. And we also, to ensure that we can easily find the map the tests and their source code, we replicate the structure of the source code inside the tests folder. So this way you can easily find the test for your source code. And this is important. So it's very often that you see that one test tests has several things. Don't do that. It makes it very difficult to maintain and very easy to break. So break it down into very simple tests and have one suite with a lot of tests. That's much better. Yeah, and you can also use our TypeScript starter that has the full support for running the Jest tests. So basically, if you add the tests, they will be automatically picked up. So you do it like this. And yeah, this is something we haven't really announced yet, our brand new TypeScript starter. It's basically doesn't have any examples as we used to have in our starters before, so it's just plain TypeScript and Jest. So you just add your code, add your tests, and they will be automatically built and picked up. Yeah, so very quick show time. I'm not gonna write any code because I showed you all the examples now, but what I'm gonna show is that you can actually run the tests without having XP running. So I will do the Enonic create com example Jest, doesn't matter how I call it at this point, and I will use something that we call tutorial Jest, and there is our repo which contains the, and I will increase it a bit. Can you see it? Yeah. I don't really need a sandbox because I'm not gonna run XP, but fine. I will use clean one. Just yes. And I don't want to start a sandbox. So I will just show you that I don't have XP running. Okay. So now I'm gonna go to the, and I can show you actually the, I can show you the app just to show you that this is an actual XP app. No magic, so you see the what I talked about, source folder, client and server tests, and you have one client-side test here and a bunch of tests here. And let's see now. So I can do Gradle test. And yes, it's the first time I run it, so it's gonna install some npm libraries. See now the npm test running, and 4 tests here. All of them passed, no XP running, so that's what you would want, right? You don't want to start an instance of XP and wait for it and then so everything is covered. Your tests took 1.5 seconds to run. Of course, you will be, yeah, you will have more tests, but I think we had in one project we had around thousands, something over 1,000, and it took like 5 seconds or something like that. So it's very fast. Yeah, any questions?
Can you run with npm?
Yeah, you can just do npm run test. Bam.
Yeah, can you run it with the CLI?
You should stop now, Thomas. Too many questions. But the answer is actually yes. You do Enonic project test, and this is probably something that you haven't seen yet. Testing in sandbox Jest. Passed. Okay. Yeah?
Yeah, so Jest also have integration with, or good integration with K6 for performance testing. Because this is traditional unit testing. Have you been thinking about doing anything with performance testing?
4 years now. But we have to take one thing at a time, or 10 things at a time. But we haven't gotten yet. But yeah, it's on our list.
Of course, you can do whatever.
Yeah, we already use it in our
Yeah.
pipeline. So we use Jest with K6 now.
We are getting it.
Yeah.
Yes. The Mock XP, will that only work with Jest, or could you use that with other testing?
Anything. Doesn't have anything to do with Jest.